How many liters of a 20% acid solution should be mixed with 80 liters of a 61% acid solution to make a 45% acid solution? So, 0.20 is the concentration in cup 1, 80 is the amount of solution in cup 2, 0.61 is the concentration of cup 2, and 0.45 is the concentration of the bucket at the end. We have to apply the formula amount of solution times concentration equals amount acid to all three containers, to cup 1, to cup 2, and the bucket at the bottom. So instead of pouring, as the question is asked, instead of pouring one container into another, it's actually easier to rethink of this problem as if the contents of two cups are poured into an empty bucket. So this is the picture that I think would be helpful to label. So you've got cup 1, you've got cup 2. Dump both of the containers of that. That's what the arrows here are about, into what would start as an empty bucket and would eventually have things. So notice that there's three containers, cup 1, cup 2, bucket, and all three of the containers we need to keep track of three numbers. There's amount solution, there's concentration, and amount acid. We put in all the numbers that we had already up here, and now the formula that amount solution times concentration equals amount acid, that can be used to fill in the amount of acid in cup 2, 80 times 0.61. Now, how about the amount of solution or amount of acid in cup 1? We don't know, but if we just create a variable for one of these, I'd like to create a variable x for the amount of solution in cup 1. Okay, this x doesn't represent the amount of acid in cup 1, just the amount of solution, total solution, some of it being acid, some of it not being acid. Then what we can do is apply this formula again, amount solution times concentration equals amount acid for cup 1, and have 0.20 times x. Then the amount of solution from cup 1 and the amount of solution from cup 2 should add together to produce the amount of total liquid or amount of solution in the bucket. So x plus 80 is written here, x plus 80. Now, how about the amount of acid down here? Well, there's two ways to get it. One is we can apply the formula again, amount solution times concentration equals amount acid. So x plus 80 times 0.45. So I just wrote it in the other order, but it's 0.45 times the quantity x plus 80. The thing is, the amount of acid is also just how much acid did cup 1 contribute, and it was 0.20x. How much acid did cup 2 contribute? It was 80 times 0.61. Add those together, and that is another way of getting the amount of acid in the bucket. Now the point is that the amount of acid in the bucket is written in two very different looking ways, but they're both accurate ways of describing the amount of acid in the bucket. So we set those equal to each other here, and then distribute the 0.45 on the left side. You'll notice that there's two terms on the left, two terms on the right. There are two terms with x and two terms without x. So let us get all the terms with x on one side and all the terms without x on the other by adding and subtracting terms on both sides. Now that both terms with x are on the left, factor out the variable, divide by what's in parentheses on both sides, and x equals this number. We really have x equals a number here. No point in typing this into a calculator. Recall that x represented the number of liters in cup 1, and the question was really about how many liters total should cup 1 be. So our final answer is whatever number x is, right? So just to make sure, as a review, how many liters of a 20% acid solution should be mixed with 80 liters of a 61% acid solution to make a 45% acid solution, right? So the question really was asking how many liters of the 20% acid solution. That is what x represented. So conclusion, that number, copying what x was, number of liters of the 20% acid solution should be used.